Greetings, TL 781 class. I am going to introduce Unit 4 today, or continue with Unit 4, I should say, introduce the site level safety management text that you're going to be taking care of in your readings this week. A few housekeeping notes. Please remember that weekly discussion is due Tuesday, and all other assignments are due the day before, Monday at 8 a.m. If you have any questions in working through those assignments, please just send me an email. I will try and schedule an on-site class meeting in a couple weeks. I'm not available due to some travel, but I will be in the office on occasion, so just, again, send me an email if you want to arrange for an office visit. Looking at the site-level safety management chapter in the Carter text, chapter 11, this is a pretty full chapter with regard to the content and the discussion, examples, etc. So I am just going to briefly introduce this to you, and I'll just give you some primary notes from this chapter, and then welcome you to follow up with anything after you've reviewed and read that chapter on your own. Road safety management is the process of identifying safety problems, selecting countermeasures or strategies, and implementing solutions. As we talked about, that sounded a lot like that theory of change we discussed when talking about our logic models, etc. And you'll see similarities here in working through these as well. Site level safety management is the process of identifying and addressing safety issues at high priority sites. Here we're looking not systematically or systemically at things, but more at a site level. If we have a high crash risk or hotspot type of site. Site prioritization methods can vary among agencies. We saw that North Dakota DOT was beginning to utilize or being introduced to a new tool that they might be using. That one was, again, more systemic, but they were going to be using it with some internal decisions or analysis tools as far as the sites where it may most effectively use those solutions from the system. And then site level data for getting into this type of analysis is always very important in making sure we're making the best decisions. Coming at this from an engineering perspective, they go through 6 steps in site level safety management. The schematic is actually from the Highway Safety Manual, but they start out with the network screening, just identifying locations where you could potentially, or that could potentially benefit for some treatment. Then looking at diagnosing those crash locations. What are the factors? What are the patterns that we can see in those crashes? Are there differences in severity level? Is this site primarily a property damage only type crash, and this one actually has fatalities associated with it? Then after understanding kind of the nature of the problem, we move into the countermeasure selection. And this, again, a wide variety of tools and resources for those countermeasures that you may look to, whether it's engineering or behavior, trying to understand if some combination of those may be most effective. Then we do the economic appraisal, looking at the economic benefit and the costs associated with implementing one or more of those countermeasures or a set of countermeasures. We do project prioritization after we've kind of laid out the potential sites and the potential countermeasures that we might be able to implement. Where are our funds best spent in maximizing our safety outcomes or safety improvements based on the available resources? And then following up, of course, with the famous evaluation piece, understanding in the short term, of course, if immediately after we've done something with an intervention, but then also over time. Is that benefit a sustained benefit, or do we need to go back in and do some additional work? Looking more specifically at each of these steps, the network screening, there's several options we can use in the network screening. The simplest and most basic is a crash frequency. When we look at that, we're just understanding how often we see those crashes at that particular or see a crash at a particular location. It doesn't, the way it's termed here, you're not looking at a specific type of crash although you could just look at the number of injury crashes or the number of fatal crashes, etc. Moving that a little bit further or a step further, we can start to talk about exposure. Again, here they use the typical 100 million vehicle miles traveled as the normalization factor when we're trying to make it an apples-to-apples comparison across sites, which may be very different with regard to their traffic and environment. These, however, or both of these, and this do tend to have issues, bias with the regression to the mean, and lead to inefficient safety decisions. So we can move down and kind of come up with a bit more involved process for predicted crashes using algorithms that include things like the VMT, what the land use is, road type, etc. And that safety performance function there addresses that regression of the mean by looking at a group of crashes, not just a specific crash, and allows it to prioritize sites based on highest predicted values for potential crashes and looking at systemic safety treatments. And again, that we go into in Chapter 12, but this gives you a little bit broader view of the predicted crashes. The benefit of using the predicted crashes is you're reducing that regression to the mean bias, where you may have you pick a 3 to 5 year period. It may be a site that's never had an injury crash, and for some reason, be it with weather or something that was occurring that year, there was 3 injury crashes or 6 injury crashes, and so suddenly that site, which for 20 years has had no crashes, is a priority. And is that appropriate or not? It may very well be, but this really produces some biased results when we're starting to look at an apples-to-apples type of comparison. So considering that larger group of crashes or considering those other elements in the beyond just the actual crash history or crash rate, we start to get a better idea of what the longer term risk is and the longer term benefit then would be for some investment at that site. Here's just a comparison of those network screening methods, and I've included a couple of references down here for you: the Interactive Highway Safety Design Manual and the Highway Safety Manual. I also noted a study that we did here with an expert that I'm certainly happy to contact if any of you are interested in pursuing some of the EB methods or some of the other more advanced engineering approaches to the safety topics. He would be more than happy to visit with you or perhaps consult on some type of project. And we also have some other universities that we work with. But just in summary, we should account for, if we already looked briefly at these, but when we talk about what we should consider in screening metrics, we need something that accounts for the traffic volume, of course, or preferably. Also accounts for that regression to the mean bias, where we may get, certainly with crashes, we can see it, and when we start looking more specifically at injury crashes or fatal crashes, very random type of occurrences or events. It's not a normal distribution. And then looking at that crash severity. Is it reasonable to compare property damage only to fatal crashes in the same context or figure, and not maybe introducing some relative terms that would create an unbalanced type of outcome where you're giving more consideration to the fatal crashes? So looking down that list, 3 and 4 account for crash severity. 5 is a relative severity index here. The equivalent property damage only here, what they're doing, or what we're doing, is converting to a COMET unit. So you maybe use something like cost or some other factor that your agency or you can see in the literature you've reviewed is kind of a accepted format for weighting the fatal versus a property damage only, or a disabling injury crash, or a non-disabling injury crash. Depending on your data, you may have different levels of that. So, for instance, you may decide that a fatal injury is $10 million in economic cost of life, and a injury crash is $1 million. So you'd probably use a ratio there between the two of the injury to the fatal of 10 and then to a property damage only, that may be just $1,000. And so then you would make that just a fraction of what the injury crash is, and when you're looking at your ratio. Number 8 is where we start with those safety performance functions, and those are usually preferred because they account for that non-linear relationship between crash volumes and traffic volumes. Looking at that safety performance function, if it's greater than 1, it needs a review. 9, the probability, and 10 are not affected by the regression to the mean unless you use a short time crash history. Number 11 is the empirical Bayes, which combines that predicted crashes and actual crash history. So it gives you a more general crash prediction based on real world experience, but still accounting for what's actually happening at that site. So it pulls the actual site towards what the real world average is. So that we're starting to kind of account for the randomness in our crashes there. Number 12, there we're looking at that equivalent property damage unit. So we're getting that common unit so we can look at not only the fatal crashes, if that's a crash of interest, but maybe also the injury crashes and making that conversion. Number 13, there's no severity element, but the empirical Bayes does bring in that system to balance the risk. Diagnosis, our next step, we look at identifying, after we've gotten that metric on our crash sites, how we're going to compare cross sites, we're going to start to look then at those patterns and understand factors where we have sites with the higher or more safety need or at risk for crashes. We're going to start to see if we can see some patterns and shared factors. Often in this type of approach, you'll do a field visit and take some notes and pictures and et cetera for follow-up and discussion and looking at what the best solutions are. The Hayden matrix, and I mention this because it is commonly used in the traffic safety world. It was borrowed from the medical field and is used to kind of understand the pre-crash, crash, and post-crash factors and what may be coming into the mix as contributing factors, and therefore may be available for something that you maybe would look at as a countermeasure. The Highway Safety Manual recommends in this diagnosis to review safety data. That includes the police reports, the geocoding of the crash locations, condition diagrams, etc., and then assessing supporting documentations, just for instance, with that site visit you've done. Also, perhaps you've interviewed some of the local police officers or some of the maintenance and the EMS folks and have that to take into account, and then just assessing the field conditions. Maybe you want to go, like I said, the site visit, but not only that single site visit, but maybe you want to travel it at different times or using different modes, looking at the traffic mix, what potential conflicts are, what road speeds are, and just making mental and then eventually project notes about some of those items. Something else that may be used for a specific site more formally is a road safety audit, and I included an example of one of those here later that we worked on and that I've mentioned previously. Just to touch on that Hayden matrix, it identifies the risk factors pre-crash or before the crash, during and after, and any relation to the different factors in the crash, the human, the vehicle, and the environment. And it can be an analytical tool to really help you identify all those crashes that are associated with a particular site or a particular crash type. We're speaking generally here with regard to crashes. You can also do these for very specific things, like for an intersection crash or for an older driver crash, and kind of lay out these factors. So this kind of fits into our logic model in a way, understanding what our problem is before we go into the solution or countermeasure portion of it. And speaking of those countermeasures, we need to understand the crash contributing factors that we just talked about in the previous. I have vehicle in there twice, just once on the vehicle, and identify targeted countermeasures, and then estimate the safety impacts. Here I mentioned the crash modification factors. If it's less than 1, when you're looking at safety impacts, it should reduce crashes. And the text provides an excellent discussion of those crash modification factors. So just touch base on that. Keeping in mind that some countermeasures may decrease crashes of some type, but increase others. And you're hoping in the end that you're decreasing those that are more severe. And although that may increase some of or even in the short term, even perhaps may increase some of the other crash types while people are adjusting to the change. Hopefully it's the less severe crashes, the property damage only, and if it is an injury, hopefully a non-disabling, but we're trying to reduce the injuries and severe injury crashes. Crash modification factors should be applied to situations that closely match those from which the CMF was developed. So therefore, if there was a crash modification factor that was developed in an urban intersection in Minneapolis or Chicago, would it be appropriate to apply that to an intersection in Fargo? Probably not. You probably want to have something that's more of a peer site application. Or would it be appropriate in an intersection in rural North Dakota for 2 rural highways? And there it would be a definitely not appropriate application. So keeping those in mind, you want to understand how that crash modification factor was developed, some of the countermeasures, and I made some of those resources available within the course website, and we've discussed a few others. And if you have a special topic, there are other countermeasure guides or resources available. There are a few mentioned in the text, but just go ahead and use Google when you've selected your topic and see if you can kind of supplement what the typical countermeasure resources are in identifying and selecting countermeasures. Next, we have the economic appraisal, or the economic appraisal and prioritization, looking at steps 4 and 5. When we look at the benefit cost analysis, you have to make sure you're selecting an appropriate time period. If the life of that particular improvement is, or policy, for instance, that if the life of that is the next 20 years you want to look at, make sure you're selecting a full 20-year to run your discount rate and your net present value for your benefit and present value for your cost. There may be some sunk investment at the front end of that, and you'll need to consider that. You may also look at a benefit cost ratio. There we're looking at just the present value of that benefit in relation to the present value of that cost. And there's, again, some good examples in the text of those. You can also, if you have more limited information, we can look at a cost effectiveness index where we look at the present value of the cost divided by the crash rate. So how much is it going to cost per crash unit of crash reduction? And then just looking at, you may use more than one of those and prioritizing overall with regard to the economic effectiveness. And I did want to side note on this. I know or understand that Pam is covering this, and we'll also touch on this when we get into the evaluation portion of the course. But keeping in mind when you look at the benefit cost analysis, it's often based on injury costs when we're talking about traffic safety. And you can see that there are there's a kind of a wide range in what people or agencies use with regard to the cost for an injury, and these can also be used in those ratios when we're looking at equating a PDO to a fatality, etc. Here you can see the Highway Safety Manual, the fatality, when they're talking about a comprehensive crash cost there, is about $4 million. When we're looking at the economic cost or full social cost of loss of life, it's about $10 million, and that one is from a National Safety Council source. So keeping in mind, again, if you put those numbers into your your analysis, you may come up with some very different outcomes. Also, make sure you're using an appropriate discount rate. I have usually looked to public investments as a more conservative discount rate. Using stock market return may be justified, but you would have to account for that in what you are doing. Something else that's common is using scenario analysis, where you aren't sure if a discount rate should be at a certain point, so you make it a range and look at it with plus or minus to that specific discount rate. The same could be done with the injury costs. I just included in here, you can also pull some of these up through other online sources. You'd have to count for time value of money in, but this is looking at some of the costs just to give you a feel for what it might cost to install chevrons or educate young drivers. They don't include an estimate there, but you'd use an hourly rate for someone in that profession, and decide then also media to try and understand how that would fit in. Installing signs, pavement markers, then we have some medium cost of strategies such as the striping. Guardrails gets to be more involved, and also not only that initial investment, but also the maintenance costs for those, and what it means for maintenance folks who are doing snow removal and grass cutting, etc. Other things we can look at, some of those rumble strips, rumble stripes, and shoulder flattening. We've looked at kind of some of those in the examples we've discussed earlier. I just wanted you to be able to put kind of a relative cost to those. Evaluation, looking at that final step, there's two forms of evaluation that typically you would go down or paths, the experimental or the observational. Experimental, as you can understand, is probably not widely used, and that has to do with liability. If you would go in and try and experiment with something that is not tested or not proven, and you have a crash, you could be, or the state or the local agency could then be liable for any kind of injury costs or outcomes in that. More common is the observational, and there's some different approaches here as well. We can use cross-sectional or a before-after approach. We have used the cross-sectional, where we have looked at some of the control versus a cohort where they've had the intervention, and then also looking at the before and after. There is potentially some bias with all these, or with both these, in the cross-sectional, so you may want to look at the EB before after to minimize the bias. And as with many of the other things we've discussed in this lecture, there are some excellent examples in the text, and I'm happy to follow up with you if you want to have additional experiences or exercises with any of those type of approaches. The cross-sectional Carter text has a good example of a shoulder widening from 3 to 6 feet. And then looking at the case control sites, so we're talking about, for instance, you pick based on a crash or no crash and look at the site prior. The issue with those, of course, you have those confounding factors, and so how can you do that cause-effect type of relationship? We used the cohort method, in the North Dakota rumble strip study. I think I mentioned that it was early in the class, where we compared where they had installed or improved the roadways with those rumble strips when they started the statewide program. We looked at those places that had been touched initially in the first 3 years compared to the same type of roads that had not been improved with the rumble stripes, although they were eventually, or strips, they were eventually completed statewide. We did have an opportunity and were able to look at that as an improvement, and in a cohort method for that cross-sectional analysis. This is one example I mentioned, I think at the last class, where we did a road safety audit. We called it a traffic safety evaluation. It's referenced on our website that way. But we had a corridor. It's a National Scenic Byways. And so we did a site visit, being a corridor visit. So there were 3 sites along this corridor, and I'm just going to touch on one of these. It was a day-long tour, we'll call it, of the corridor with there was a law enforcement officer involved, EMS involved, someone who works with that scenic byway from the program or the National Scenic Byways perspective, and then also someone from maintenance and the county road engineer. And this is a curve that is just north of Valley City here, and you can see the section line here continues, but they later decided when they made it a highway to make this a curve and follow up, or this is actually looking south, going south down the road based on what was available for other roadbed opportunities, because there is another road that intersects this one right on the edge over here as well. So the law enforcement had said they had reported several near misses here. There used to be some skid marks, they said, and often during the winter when the snow was deep, there would be vehicles parked out in this area that had run off the road. Some of them remained there for the winter because they weren't able to pull them out due to the snow, etc. So this one was prime. There along this whole corridor, there was 79 crashes. There was 1 fatality and 13 injuries. And I believe this one was not, the fatality was at a different site, but this one had some injuries associated with it. So after the meeting, and they did we did a Delphi survey after this to identify some of the priorities and investments. The improved, decision for the improved was to install chevrons. And since they've installed the chevrons, which has been about 6 or 7 years ago now, there have been no vehicles that we've been observed that have stayed in the ditch or gone in the ditch during the winter that were associated with looking like the drive off the edge of the road or drive through that path where it often looked like they should be going next when you would approach us in the dark prior to the chevrons. They also added this curve warning sign to give drivers a little bit more of a heads up, since again it's a National Scenic Byways, so they get more tourism travel than they would typically. I'll also mention this study, the Wyoming Rural Road Safety Program. If, again, you want to look at something, this is a systematic study where they looked at crash data for several tribes in their state, and they did go through all those steps in identifying sites and determining where the intervention should be made. I left a reference down here for you. And we work with Dr. Kasabi on an ongoing basis. So again, if this is something or along those lines that you would like to pursue, I am more than happy to contact him. He would, I'm sure, certainly work with us on a project if we wanted to do something in North Dakota in this area. So that is my quick introduction, or not so quick, but quick introduction to Chapter 11. And next week we'll quickly go through Chapter 12 and finish out our work with the Carter text in moving on to the evaluation portion of the course. Assignments this week, as usual, readings and resources should be kind of do that or overview those prior participating in the discussion and completing the unit activities. We have that weekly discussion again, and a little bit different this week, you'll see. The team assignment for the innovative low-cost safety intervention, I moved that forward a week. I just decided with coordinating in a group like you are, it may be easier and better. I know you will have another assignment also due October 1st for next week, but for right now, I'm just going to move that out a week. So You'll have 2 assignments due October 1st, but I thought that a little additional time for coordination might be good. And I'm going to try to set our next meeting for October 10th. Probably not noon, it'll be at 1 o'clock, I think, or shortly thereafter. But I'll send out an announcement to confirm. That kind of depends on how the final schedule comes together for that week. So I thank you and good luck with your next few weeks of class.